Okay, today's topic is combining radicals. So we're going to do operations with combining radicals. We're going to add, subtract, multiply, and divide radicals. So first, we're going to fill in some of these blanks here. So the first one we're going to fill in is we're going to combine like radicals. It's very similar to combining like terms, what we did with the algebra with the polynomials. So we're going to combine like radicals, very similar to combining like terms. Next, you may have to simplify the radicals first. Talk about that here. We're going to simplify the radicals first. So, have some of these examples. So we have this one. Have 4 square roots of 3 plus 6 square roots of 3 minus 5 square roots of 3. So this one's simple. All we have to do is just add or subtract the numbers out in front. So 4 plus 6 is 10. 10 minus 5 is 5. And since the radicals are the same, we're going to do 5 square roots of 3. So this problem over here, we have two sets of like terms. So we're going to combine the 12 square roots of 5 and the 8 square roots of 5. So we're going to do 12 minus 8 and we get 4, and it's going to be the square root of 5. Next we have 3 square roots of 7 plus 6 square roots of 7. So 3 plus 6 is 9, so we have 9 square roots of 7. So that is that problem right there. And it's simplified. Now this one, over here. Alright, so this one, we have 1 to the third root of 2 plus 1 to the fourth root of 3 plus 5 to the third root of 2. So we're going to add 1 plus 5 and we get 6. We have 6 to the third root of 2 plus to the fourth root of 3. And that's a 1 there. So we have 6 to the third root of 2 plus 1 to the fourth root of 3. So that's what we have there for our answer. Now this one, this problem right here, it is a not nice problem. So first thing we have to do is we have to do our factor tree. So we're going to do a factor tree. We've got to do a factor tree at 20. We have to do it at 45. We have to do it at 180. So of 20, so we're going to get all the work right here. So if you guys can go ahead and see what I did. So we have 4 square roots of 5 plus 9 square roots of 5 plus 6 square roots of 5. So we have 4 square roots of 5 plus 9 square roots of 5 plus 6 square roots of 5. So all I did here was do the factor tree, is what we did in class previously. And then we're going to combine our like terms. 4 plus 9 plus 6, and we get 19. So our answer is 19 square roots of 5. Okay, next problem. We have this right here, 6 square roots of 27 plus 8 square roots of 12 plus 2 square roots of 75. So what I did here was I did the factor tree, and you guys can go ahead and see the work here. And we end up with 18 square roots of 3 plus 16 square roots of 3 plus 10 square roots of 3. And then we're going to combine our like terms. 18 plus 16 plus 10 gives us 44. So we end up with 44 square roots of 3. And over here, now this problem right here cannot really be well, we can simplify it some, but that's about all we can do because we can't combine anything here. So the only thing I was able to do with this problem, I just simplified the fourth root of 80, and I simplified the fourth root of 32, but I couldn't combine anything, so it just ended up with 2 to the fourth root of 5 minus 3 to the fourth root of 80 plus 2 to the fourth root of 2. So that was all I was able to do. All right, next, we're not going to worry about this over here. Just going to worry about these words over here. So when we multiply radicals, what we're going to do is multiply the outside numbers. First, we're going to multiply the outside numbers. We're going to multiply the inside numbers. Those are the numbers inside the radical. And then we're going to simplify if needed. So we're always going to simplify the radicals as needed. So first example, we have square root of 3 times square root of 15. So we're going to multiply that. 3 times 15 is 45. So we have the square root of 45. And we are going to simplify that. So there's the factor tree. So when we simplify our answer, we're going to get 3 square roots of 5. So our answer for this one is going to be 3 square roots of 5. Next problem. is 3 squared root of 2 times 4 squared root of 24. So 3 times 4 is 12. 2 times 24 is 48. And then here is the work with the factor tree. And when we multiply them together, 12 times 2 times 2, and we got the 3 left over, so the 3 is out in the radical. 12 times 2 times 2 is 48, so we end up with 48 square roots of 3. Then last problem on this row, we have 7 square roots of 30 times 2 square roots of 6. 7 times 2 is 14, then 30 times 6 is 180. Then we do the work with the factor tree, and there we go. You can pause it as needed so you guys can see where the numbers are coming from. And then we end up with 84 square roots of 5. So we end up with 84 square roots of 5. Excuse me. Next problem. All right. We have this square root of 6 on the outside of the radical. So we're going to multiply this square root of 6 times both of these terms on the inside of the parentheses. Then I end up with square root of 18 plus 5 square roots of 12. Because remember, we're multiplying radical times radical. So we're going to factor tree both of those. There's the work with the factor tree. Then we end up with 3 square roots of 2 plus 10 square roots of 3. All right, next we have 4 square roots of 5 times 2 square roots of 10 plus 3 square roots of 2. So we're going to multiply. Outside times outside, we get 8 square roots of 50 plus 12 square roots of 10. So we do the outside times outside, inside times inside. So again, you guys can go ahead and pause as needed so you guys can see where the numbers are coming from. And also, while you guys are watching the videos, please be sure to raise your hand if you guys have a question, so I can go ahead and try to explain some things to you. All right. Now we have this 8 square roots of 50 plus 12 square roots of 10. We're going to factor tree that. So remember, we're always going to factor tree. Now the reason why I didn't factor tree 10 is when you factor tree 10, you get 2 and 5, and both of those numbers are prime. So 2 and 5 are prime, so you can't really simplify it, so that's why it stays 10. So factor tree, and here's the work, and we get 40 because you pull out a 5. 8 times 5 is 40, so we get 40 square roots of 2 plus 12 square roots of 10, and that is the answer for this problem. All right, now for this one right here, I only want y'all to pay attention to that problem. We're not going to pay attention. We're not going to worry about the one on the right, because that one doesn't simplify. So we're just going to focus on this one. This is just like FOIL. So we're going to FOIL. So we're going to do first times, multiply the first terms together, or do the outside terms together, do the inside, and then do the last term. So first, 2 square roots of 10 times 3 square roots of 3, and I end up with 60 square roots of 3. Then 2 square roots of 10 times negative 2 square roots of 2. End up with negative 4 square roots of 20. Then multiply the inside terms. 3 square roots of 15 times 3 square roots of 3. End up with 9 square roots of 45. And then do 3 square roots of 15 times negative 2 square roots of 2. End up with negative 6 square roots of 30. So that's what I end up with. And then we're going to combine our like terms, which is 6 square roots of 30 and the negative 6 square roots of 30. And those cancel out. So now we have negative 4 square roots of 20 plus 9 square roots of 45. Factor tree those. And those can't simplify. And then just like we did with the other problems, we can combine our like terms or like radicals and end up with 19 square roots of 5. Okay, last page. All right, first blanks. You are not allowed to have a radical in the denominator. That's a math rule. You guys cannot have a radical inside the denominator. All right, so again, you're not allowed to have a radical in the denominator. All right, next, to get rid of the radical, what we're going to do, we're going to multiply the top and bottom by the denominator, or whatever's in the denominator, or the conjugate. What is the conjugate? The conjugate is the same denominator, but you have different signs. We're going to have some examples here in just a minute. So the conjugate, same denominator, but different signs. All right, and then this way, the radicals will cancel each other. So the radicals will cancel when you guys multiply by the conjugate. All right, so these are some examples when you're going to have a conjugate, where you have a number plus a radical. So we have a number plus a radical. It's going to be that same number minus the radical. So you're just going to do the opposite sign. And this time, in this case, we have a number minus a radical. So we're going to do the number plus a radical. So that's the conjugate, where you do the opposite sign. So we got these examples here. All right, so we have 10 squared root of 3. The square root of 10 divided by the square root of 3. So what we're going to do, we're going to multiply by the denominator, which is square root of 3. And we get 30 square roots of 3. So we get 30 square roots of 3. We're going to factor tree 30. Oh, we factor tree 30. So we end up with square root of 2. So we're going to end up with 2 square roots of oh snap. Oh, sorry. There was a reason why I had this one marked out. Y'all forget the last thing I said. This is just going to be the square root of 30 over 3. Because none of the radicals, none of the factors here can go ahead and get paired up. So we're going to end up with square root of 30 over 3. So we're going to end up with the square root of 30 over 3. So there's nothing here, nothing here. It's just the square root of 30 over 3. Okay, next problem. We have the square root of 12 over the square root of 5. We have the square root of 12 over the square root of 5. And we're going to multiply top and bottom by the square root of 5. And that gives us square root of 60 over 5. I forgot to explain. What happens when you multiply the square root of a number by the same number? It just becomes that number. So the square root of 3 times the square root of 3 is the square root of 9. But the square root of 9 is 3. So that's why we just end up with the same number, just drop the radical. So in this case, square root of 5 times square root of 5, it just gives us 5. So now we have square root of 60 divided by 5. We're going to factor tree 60. We get 2 square roots of 15. So we get 2 square roots of 15 over 5. So that's what we have there. All right, just have a few more problems. All right, next one. We have the square root of 3 over the square root of 8. So we have the square root of 3 over the square root of 8. So multiply the top and bottom by the square root of 8. And that gives us square root of 24 over 8. Because remember, square root of the number times the square root of the same number. Just drop the radical sign, use that number. We're going to factor tree 24. We're going to factor tree 24. And there's the work. So we're going to end up with 2 square roots of 6 over 8. The 2 and the 8, we can reduce that. So we're going to end up with the square root of 6 over 4. So we're going to end up with the square root of 6 over 4. All right, next problem. Have 2 square root of 2 divided by the square root of 6. We have the square root of 2 divided by the square root of 6. So we're going to multiply the top and bottom by the square root of 6. So we end up with the square root of 12 over the square root of 6. And over here is the work with the factor tree. And then when we simplify that, we get the square root of 2. We get 2 square roots of 3 over 6. And then 2 over 6 reduce. And that's going to be square root of 3 over 3. So that's going to be the square root of 3 over 3. All right. All right, so because the time is short, I'm just going to go ahead and show these last problems. So here's that one. And the answer for this is square root of 3 over 5. And here are these two problems. And here's